Example 4, the mean score on the Math MCAS grade 10 level was 515 in 2000. An educational researcher claims that students who study algebra in the 5th grade have higher scores. He obtains a random sample of 40 students from schools who have students do algebra in the 5th grade and finds that their mean score is 540 with a standard deviation of 90. He wishes to test the claim at the alpha equals 0.05 level. So what kind of score is it? Or what kind of test is it, excuse me? It's a mean test. The original mean score was 515. So our null is the mean is 515. Our hypothesis is that the mean score is higher. So the mean greater than 515. And our alpha is 0.05. Oops, I wrote it again. Our sample data was 40 students, sample size 40, with a mean score of 540 and a standard deviation of 90. So our sketch of the sampling distribution was a mu sub x bar of 515, and our sample x bar is 540, and we shade the p-value to the right. So our probability that x bar is greater than or equal to 540 is equal to our p-value, and we would like that to be less than or equal to alpha, which is 0.05. Okay, either you're getting it or you're falling asleep. Not sure which. Number 5. We have, according to a 2010 survey, the mean number of apps downloaded by iPhone users is 40. Suppose that a sample of 36 iPhone users downloaded an average of 45 apps, and the sample deviation was 24. Test whether the population mean number of apps has changed using alpha equals 0.10. So again, it's a mean. And we're looking at original data that the mean was 40 apps. Now they're asking if the mean number of apps has changed, but they're not saying whether it's less than or greater than. So our alternative hypothesis is going to be the two-tailed test, that the mean is not 40, because we don't know if we're looking for it to be less or greater than before we collect our data. Our alpha in this case is 0.10, which is a higher alpha because it's not like life or death whether or not people have more apps. So we're looking at the mean. Our sample mean was 45. Our sample standard deviation was 24, and our sample size was 36. So our picture is our mu sub x bar was 40, and our data was x bar is 45. So again, this is our p-value. So the probability that x bar is greater than or equal to 45 is equal to the p-value. I wanted to highlight this one because it's a two-tailed test. Because it's a two-tailed test, we have to use alpha over 2 as our test value. So we want our p-value to be less than or equal to alpha over 2 because it's a two-tailed test. So instead of looking at comparing to alpha, we have to use both sides. So alpha over 2, alpha over 2. So it's harder to pass a two-tailed test. Any questions? It's rare that you run into a two-tailed test, but I figured I'd put one in here. All right, we have one left. So the National Institute on Alcohol Abuse and Alcoholism reported that 46.5% of 8th graders had used alcohol. A random sample of 100 8th graders showed that 41 of them had used alcohol. Is there evidence that the population proportion has changed, tested at the alpha equals 0.01 level? So in this case, we're talking about a percent. There's no word mean there. So we have a proportion, which means both of our hypotheses are about P. Our original hypothesis uses that it's 46.5% or 0.465. And our P, we're looking for a change, so a not equal to 0.465, with our alpha being 0.01. So again, we have a two-tailed test we'll have to be careful about. Our proportion figures for our sample are 41 out of 100. So here is our picture. Our mu sub p hat is the same as p, so it's 0.465. We got 41 over 100, so our p hat is 41 over 100, or 0.41. So our data is actually going to be over here, our p hat. And there's our shading for our p-value. So our probability in this case is going to be the probability that p hat is less than 0.41. And that's going to be equal to our p-value, which we need to be less than alpha over 2 because it's two-tailed. And that would be 0.01 over 2, which is 0.005. Really small. So it's unlikely to happen. Okay.
So if it's not two-tailed, would it be alpha over 1?
Yeah, it's just alpha if it's a one tail.
Oh, okay.
Either left or right. Any other questions?